let's say I want to factor something where the constant term is not exactly just a number. We've got both x's and y's here, and I want to see if it's possible to use the AC method for something like this. The AC method referred to the method where all quadratics come in the form of ax squared plus bx plus c. A was the number attached to the x squared, b is the number attached to the x, and c was the term that's alone. So is it possible to apply the AC method to something complicated like this? Well, here our a would be 1, since we don't have anything in front of the x squared term. It's assumed to be a 1. But b would not just be 5 here. b could be thought of as 5y in this case. And c, the term that's alone, would not be just 6, but 6y squared. Could the AC method still apply? Let's see if it could. So in the AC method, you're supposed to, on the side, multiply the a times the c. So in this case, if we applied that to this situation, multiply the 1 times the 6y squared, and that's obviously going to be 6y squared. We would now look for factors of 6y squared that would not only multiply to 6y squared, but also add to the b term. Right, so it could be that it's 1y times 6y, or let's say 2y and 3y. We could have negative 1y, negative 6y, negative 2y, and negative 3y. The special combination that we're looking for is 2y and 3y. They would multiply to 6y, but they would also add to the middle term of 5y. So what I'm saying is, in the AC method, you want to check. Do they multiply to a times c? 2y times 3y makes 6y squared. That checks. Do they add to the b term? 2y plus 3y makes 5y. So that checks. So that's the special combination. The technique says now that you're supposed to break up the middle term using the combination that you found. But remember that we have to attach these numbers to the variable x. So this would make 2xy plus 3xy. And then we'll bring the other terms down. Okay, now it's rewritten. And so the next step in this is to group pairs of terms together. So group this guy and that guy. And then we'd factor out what we can. So here, they share x. So pull the x out front and divide by x. These guys would share a 3y, it looks like. So pull that out front and then divide by 3y. X plus 2y. There we go. Now, the common binomial comes out front. And what gets left behind is these here. All right, let's FOIL it just to check. You do your firsts. It's x times x. Makes x squared. Then you do your outers. X times 3y makes 3xy. Then you do your inners. 2xy. And then your lasts. 6y squared. So it's x squared plus 5xy plus 6y squared. It matches.